Okay, so to start with, we're going to be looking at Malus's law, which states that if you have polarized light, so drawing this here, the light is polarized vertically and propagating in the x direction, and it's incident on a polarizer. So this is an analyzer filter, and the polarization axis here is drawn at an angle theta to the vertical. Then the transmitted light will be, as a function of the angle, will be the incident intensity times cosine squared of the angle. So what this means is I have a linear polarizer here, and so this filter transmits light that's polarized with the electric field oscillating in this direction. So if I take another linear polarizer and put it across at right angles, then nothing gets through. If I line them up, nearly everything gets through. The polarizers aren't perfect, so there's a little bit of loss. Even if they're perfectly, even just going through one polarizer, you can see this is a little darker than the paper behind it. So there's a little bit of light that doesn't make it through. If I cross them also, it's not exactly perfect. You can see almost none of the light's getting through, but there is a little bit if we measure it carefully. But in general, if I cross them at a variable angle, you can see you get a variable amount of transmission through them. So on the table here, I have set up a laser projector, which is just a laser pointer and a little holder and a piece of frosted glass and this lens here. And what the lens does is enlarges the spot and lets me project it onto the screen on this side. This is a nice big laser spot. To my eye, it's pretty uniform brightness, and it's the same green color all the way through. On the camera, it's kind of blowing out because of the exposure. And then I've got some polarizers in the middle we can put in the optical path and look at a few different things. So because the eye is very sensitive to light and can detect light over many, many orders of magnitude, and because of the exposure issues with the camera, we'll take a look at some polarization effects on the screen visually, but also I've got a little light sensor here behind the screen that we can move the screen out of the way and actually perform some intensity measurements so we can check this stuff numerically. So to start with here, we've got our laser projector going through a vertical polarizer. So all the light that's hitting the screen over here is vertically polarized, that is with the electric field oscillating up and down. And if I put a second polarizer behind it that's also vertical, you can see it doesn't really change the picture much. We've still got our laser dot over there. The second one is in a rotating housing though, so I can start to turn it, and there's 20, 40, 60, 80, and 90 degrees right there. And like I said before, the polarizers aren't perfect, so there's a little bit of light that gets through even when they're crossed, but if I keep going, we'll see that this is a minimum here at 90. So now 100, 120, 140, 160, and 180. So now the rotating polarizer has been rotated through 180 degrees, so it started vertical and it's back to vertical now. And I can keep going 200, 220, 240, 260, and 270 with the minimum right there. And then 280, 300, 320, 340, and finally back to our original orientation. Okay, so I've got the light sensor behind the screen now, and I'm set up to record the intensity of the incident light. So yeah, let's give it a shot.